In a world increasingly defined by the relentless march of technological progress, where consumerism dictates a constant upgrade cycle and obsolescence is designed into every product, there exist communities that steadfastly chart a different course. They are an anachronism to some, an inspiration to others, the old order Amish. Their lives are a deliberate rejection of many modern conveniences, yet this does not equate to a rejection of ingenuity or hard work. Quite the opposite. For these communities, necessity is not just the mother of invention. It is the forge upon which self-reliance and communal strength are tempered. Our story takes us into the heart of one such community, not to observe a quaint custom, but to witness a profound act of creation. The construction of an essential piece of farm machinery, a hay mower, built entirely from scratch. This was no simple assembly job, no kit from a catalog. This was a complex, multifaceted engineering challenge, undertaken with skill, patience, and a deep understanding of mechanical principles, all while adhering to the strictures of their faith and their unique way of life. The finished machine, a testament to their craftsmanship, would be valued at an estimated $3,000, not merely for its material cost, but for the countless hours of skilled labor, the shared knowledge, and the profound independence it represented. It is a narrative that speaks not only to the practicalities of farming, but to the enduring human spirit of problem-solving, resilience, and the quiet dignity of building something meaningful with one's own hands. The Amish way of life, guided by the Ordnung, an unwritten set of rules and traditions, dictates a deliberate separation from much of mainstream society. This separation is not arbitrary. It is rooted in their theological convictions, emphasizing humility, community, plain living, and a rejection of pride and worldly influences. For generations, this has translated into specific guidelines regarding technology. They typically forego grid electricity, automobiles, televisions, and many forms of modern communication. Yet, their existence is far from primitive. Instead, it fosters a unique relationship with technology, one characterized by adaptation, modification, and a profound emphasis on self-sufficiency. Agriculture lies at the very core of Amish life. It is not merely a profession but a way of life, a means of sustaining their families and communities, and a direct connection to the land and the rhythms of creation. Their farms are often multi-generational endeavors, relying heavily on horsepower rather than internal combustion engines for field work. This reliance presents a unique set of challenges in an age where most farm equipment is designed for tractors and industrialized agriculture. Buying new commercial equipment can be prohibitively expensive, often requires significant and costly adaptation for horse-drawn power, and may contain technologies or design philosophies that conflict with their ordnung. Modern machinery is frequently built with planned obsolescence in mind, making repairs difficult and parts scarce after a few years. For the Amish, durability, repairability, and simplicity are paramount. The need for robust, reliable farm machinery is constant. Hay, for instance, is a critical crop. It forms the primary feed source for their horses, dairy cows, and other livestock, especially through the long winter months. The timing of the hay harvest is crucial, demanding efficient and dependable equipment. A breakdown during the short window of good weather can jeopardize an entire season's feed supply, with severe economic and practical consequences for the farm and the community. Therefore, the ability to maintain, repair, and, when necessary, construct their own equipment is not a luxury. It is a fundamental pillar of their economic and cultural survival. Historically, Amish communities have always been adept at adapting and building their own implements. From modifying old horse-drawn plows to repurposing discarded components, their workshops have long been hubs of innovation. This tradition of ingenuity is passed down through generations, not through formal schooling, but through apprenticeships, observation, and direct participation from a young age. Boys learn metalworking, carpentry, and mechanical principles by assisting their fathers and uncles, absorbing the knowledge and skills that will one day allow them to build or fix almost anything their farm requires. The construction of a hay mower from scratch, therefore, is not an isolated incident of extraordinary skill, but rather a powerful manifestation of a deeply ingrained cultural practice. It speaks to a collective ethos that values practical knowledge, communal labor, and a steadfast refusal to be beholden to external markets for their most basic needs. It is a testament to a philosophy that sees value not just in the end product, but in the process of creation itself, in the hands that shape the metal and the minds that solve the mechanical puzzles. The genesis of this particular hay mower project, according to community members, stemmed from a confluence of factors. An older, existing mower had finally succumbed to years of arduous service, its frame rusted, its bearings seized beyond practical repair, and its cutting bar beyond economic salvage. The cost of a new, horse-drawn equivalent was exorbitant, if one could even be found that met their specific requirements and technological guidelines. Furthermore, the community's needs for increased hay production capacity had grown, necessitating a more robust and efficient machine than their previous models. The decision was made, not lightly, to embark on the ambitious task of building a new mower from the ground up. The initial phase was less about blueprints and more about communal discussion and shared experience. There were no formal engineering drawings. Instead, older farmers and skilled craftsmen gathered, discussing the strengths and weaknesses of past machines, sketching ideas on chalkboards or scraps of lumber, and relying on a collective memory of mechanical principles. They considered the type of mower, a sickle bar, known for its clean cut and suitability for horsepower, and debated the optimal cutting width, the drive mechanism, and the materials that would ensure longevity and ease of maintenance. The goal was not merely to replicate an existing design, but to improve upon it, to build a machine that was strong, reliable, and perfectly suited to their specific farming practices. Material acquisition was a critical early step, a treasure hunt guided by resourcefulness. Raw steel stock, angles, flats, rounds, and sheets, was purchased from regional suppliers, often in bulk, but equally important were salvaged components. Old farm machinery, even if broken, offered a wealth of usable parts, gears, chains, bearings, and shafts that could be repurposed or reconditioned. A hydraulic power unit, designed to be driven by a diesel engine or a horse-powered adapter, might provide the necessary force for a modern cutting head or a lifting mechanism, carefully integrated to meet community standards. Lumber for the platform, seat, and other non-structural elements was sourced from local sawmills or even from their own woodlots, emphasizing sustainability and local sourcing. Every piece was scrutinized, its potential assessed, its role in the future machine envisioned. The workshop itself was a focal point of activity, typically a dedicated barn or a large shed. These spaces, often with dirt floors, eschewed conventional electric lighting, relying instead on natural light pouring in through large doors and windows, supplemented by propane lanterns or diesel-powered generators for power tools. The atmosphere was one of focused industry, the air often thick with the scent of coal smoke, hot metal, and machine oil. Tools, though not always conventional, were meticulously maintained and arranged. For hot work, a sturdy coal forge stood ready, its bellows fanning flames to heat steel to glowing temperatures. Beside it, an anvil, worn smooth by generations of strikes, waited for the rhythmic clang of hammers shaping metal. Tongs, chisels, and files were close at hand. For cutting and welding, an oxygen-acetylene torch was indispensable, its precise flame slicing through thick steel plate or welding intricate joints. An arc welder, often powered by a diesel generator or a hydraulic power unit, provided the strong, permanent bonds required for the machine's structural integrity. Sparks flew, casting ephemeral patterns against the dim backdrop of the workshop. Cold work involved a different array of tools. Hand saws, rasps, and planes shaped the lumber. For metal, an assortment of wrenches, clamps, measuring tapes, calipers, and layout tools, scribes, squares, and punches, ensured precision. Manual drill presses, sometimes modified with belt drives from a small engine or a hydraulic motor, created accurate holes for bolts and shafts. A lathe, a marvel of mechanical ingenuity, also often belt-driven or hydraulically powered, was used to machine custom shafts, bushings, and other cylindrical parts to exact tolerances. Grinders, powered similarly, smoothed rough edges and prepared surfaces for welding or painting. The build process itself was a symphony of coordinated effort and individual expertise. It began with the fabrication of the main frame, the backbone of the mower. Steel angles and channels were cut to length, meticulously measured, squared, and then welded into a robust chassis designed to withstand the stresses of field work. This required careful planning to ensure proper alignment and weight distribution, crucial for a horse-drawn implement. Next came the drivetrain. Salvaged gears, often from old transmissions or agricultural equipment, were cleaned, inspected, and if necessary, remachined. New shafts were turned on the lathe, precisely fitted with bearings to ensure smooth operation and minimal friction. Chains, often heavy-duty industrial types, were cut and joined to transmit power from the ground wheels or a PTO adapter to the cutting mechanism. This involved complex calculations and careful alignment to prevent binding or excessive wear. The heart of the mower was its cutting mechanism, typically a sickle bar. This required the careful assembly of numerous components: the long steel bar itself, the triangular knives, and the stationary guards that guide the hay and protect the knives. Each knife had to be individually bolted or riveted to the bar, and then sharpened to a razor's edge. The entire assembly needed to reciprocate smoothly, powered by a crank and connecting rod mechanism, often adapted from another piece of machinery or custom fabricated. The exact stroke length and speed were critical for an efficient cut, and adjustments were made through trial and error, guided by experienced eyes. Custom linkages and levers were then designed and installed to allow the operator to raise and lower the cutting bar, adjust its angle, and engage or disengage the drive. These mechanisms, often deceptively simple in appearance, required considerable thought to ensure ease of operation and reliability. A wooden seat, ergonomically designed for long hours in the field, was crafted and securely mounted. Finally, the entire machine was cleaned, primed, and painted, not just for aesthetics but for protection against the relentless elements, ensuring years of service. Throughout this intricate process, the communal aspect was paramount. Multiple individuals, each with their own specialized skills, worked in concert. Younger men learned from their elders, observing the precise arc of a weld, the careful measurement of a shaft, or the technique for sharpening a sickle knife. Discussions were frequent, problems were tackled collaboratively, and solutions emerged from a pool of shared wisdom. One might specialize in welding, another in machining, a third in carpentry for the wooden components, but all contributed to the overarching goal. Challenges were inevitable. A gear might not mesh perfectly, a bearing might be difficult to source, or a design flaw might become apparent during a dry run. These hurdles were met with patience and persistence, often requiring creative solutions, such as fabricating a missing part from scratch or modifying an existing one to fit a new purpose. The careful testing of mechanisms by hand, turning gears, and moving levers allowed for fine-tuning and adjustments before the final assembly. The culmination of months of meticulous labor, communal effort, and unwavering dedication arrived with the first field test. It was more than just a mechanical trial. It was a moment charged with anticipation and quiet pride. The hay mower, now a complete and formidable machine, gleamed in the morning sun, its fresh paint a stark contrast to the seasoned wood and polished steel. Horses, specifically chosen for their strength and steady temperament, were harnessed, their powerful muscles ready for the task. The operator, often one of the lead builders, climbed onto the wooden seat, a blend of concentration and satisfaction etched on his face. With a gentle command, the horses moved forward, the ground wheels of the mower beginning to turn. A lever was engaged, and with a soft whirring sound, the sickle bar sprang to life, its sharpened knives oscillating rapidly. As the machine entered the field of tall, ripe hay, a collective breath was held. Then, with a clean, satisfying swish, the hay began to fall in neat windrows behind the mower. The cutting was smooth, efficient, and precise. The horses pulled steadily, the machine tracked true, and the mechanisms, so painstakingly crafted, worked in perfect harmony. The initial test was a resounding success, a testament to the foresight, skill, and sheer perseverance of the community. Any minor adjustments needed after this inaugural run were quickly noted and implemented, ensuring optimal performance for the season ahead. The estimated value of this hay mower, at around $3,000, extends far beyond a simple accounting of raw materials. While steel stock, gears, bearings, and other components certainly contributed to the monetary cost, the true value lies in the immense investment of skilled labor, intellectual capital, and communal spirit. If one were to assign an hourly rate for the design work, the forging, welding, machining, and assembly, the figure would easily dwarf the material cost. This $3,000 represents not just a machine, but an embodiment of independence. It signifies the community's capacity to meet its own needs, to remain self-reliant in an age of mass production, and to avoid the financial and philosophical compromises often associated with purchasing commercial equipment. Furthermore, this project reinforces a profound commitment to sustainable practices. By building a machine to last, one that is inherently reparable with common tools and readily available parts, the Amish reduce their consumption and their reliance on a disposable economy. This mower is not designed for obsolescence. It is designed for generations. It will be maintained, repaired, and even rebuilt multiple times over its lifespan, minimizing waste and maximizing utility. The knowledge gained in its construction will be passed down, ensuring that future generations possess the skills to keep it, or a similar machine, operational. This hay mower, born from necessity and forged in a spirit of collaboration, serves as a powerful symbol of the Amish philosophy. It demonstrates that true progress is not always measured by speed or complexity, but often by resilience, ingenuity, and a deep connection to one's values. In a world that often sees traditional ways as limitations, the Amish demonstrate that they can be sources of immense strength and innovation. Their ability to construct such a vital piece of equipment from scratch speaks volumes about their craftsmanship, their resourcefulness, and their unwavering commitment to community. It is a quiet revolution, enacted one weld, one gear, one shared effort at a time, proving that self-sufficiency remains a potent and valuable ideal, even in the 21st century. The hay mower, cutting swaths through the fields, is not just harvesting feed. It is affirming a way of life, one season after another.